So today I will be presenting our work on HiQuE, a hierarchical question embedding network for automated depression detection. So in this presentation, I will introduce how our model leverages the hierarchical structure of clinical interview questions to improve the accuracy of depression diagnosis. By analyzing both primary and follow-up questions across multiple modalities, HiQuE demonstrates significant improvements over state-of-the-art models. So our experiment on the diverse dataset showed the clinical potential of this approach, particularly in early intervention for individuals experiencing depression. So now that I've given you a brief overview of today's presentation, so let's dive deeper into the problem we're addressing and the motivation behind our work. So in this section, I'll explain the importance of depression diagnosis in clinical settings, the limitations of existing approaches, and how our proposed HiQuE framework aims to overcome these challenges. In clinical settings, depression is often diagnosed through interview-based assessments where mental health for professionals evaluate both verbal and nonverbal symptoms, such as speech patterns and facial expressions and behaviors. This process involves structured questionnaires and follow-up questions to understand the patient's condition comprehensively. The hierarchical nature of these interviews enables clinicians to gather a deeper understanding of depressive symptoms, leading to more accurate diagnosis. Despite many advancements in automatic depression detection, most existing methods focus on a single modality, either analyzing verbal cues such as speech patterns and word usage, or nonverbal cues like facial expressions and acoustic features. For instance, depressed individuals often show slower speech rates, lower pitch, and use more first-person pronouns. Visually, they may display reduced facial expressions or irregular eye-gazing patterns. However, these methods generally treat the input sequence as a whole, so overlooking the structured nature of clinical interviews, where primary and follow-up questions are used to explore symptoms in depth. Recent approaches have made progress in modeling interview interactions, but they still fail to capture how the hierarchical structure of these questions influences the dynamics between different modalities. So this is where our proposed method steps in. To address these limitations, we propose HiQuE, a novel framework, and leverages the hierarchical relationship between primary and follow-up questions in clinical interviews. So HiQuE introduces interview-specific attention mechanisms to assess the mutual information between multiple modalities, inspired by how clinicians approach diagnosis. So our model is the first to explicitly categorize and analyze primary and follow-up questions, providing a more structured and interpretable framework for multimodal depression detection. And now that we've established the limitations of existing methods and the importance of leveraging multiple modalities, let's move on to the core contribution of our work, HiQuE. So our work is based on the recognition that clinical interviews for diagnosing depression followed a structured hierarchical question-answer format. So therefore, primary and follow-up questions reveal different levels of information, which we hypothesize can improve depression detection if analyzed appropriately. So in our HiQuE model, we categorize these questions and model their hierarchical relationships to capture both intra and intermodality interactions. HiQuE consists of three major components: the question-aware module, the cross-modal attention layer, and the depression detection layer. In the first stage, the model categorizes interview sequences into primary and follow-up questions. Then, the question-aware module processes each modality separately. The cross-modal attention layer integrates information across these modalities to form a multimodal representation. Finally, the depression detection layer predicts whether the individual is depressed based on this integrated information. First of all, question embedding is performed. In the question embedding process, each interview sequence is divided into question-answer pairs, and questions are assigned topic codes based on content, such as therapist, effect, or origin. So each question is further classified as primary or follow-up. This hierarchical question embedding ensures that the model captures the order and structure of these interviews, which plays a crucial role in accurately diagnosing depression. And we extract features from three modalities: audio, visual, and text. For audio, we use OpenSmile to capture key acoustic parameters like loudness and MFCCs. For visual features, we focus on facial landmarks using the CLNF algorithm. And for text, we leverage a pre-trained Roberta model to extract contextually rich text features. So this combination allows HiQuE to capture depression signals from multiple modalities in a structured way. And once features are extracted, we apply a question-aware module layer that use self-attention to focus on key questions within each modality. In this step, the input from same modality is employed for self-attention as query, key, and value. After this, the cross-modal attention layer integrates these features, ensuring that mutual information between modalities is maximized. Specifically, this mechanism allows the model to discern crucial relationships between M1 and M2 from different modalities, with M1 serving as the source and M2 as the target. And finally, the integrated information is passed to the depression detection layer, which predicts depression. So I'm going to explain our experiments. For our experiments, we use the DIGWAS dataset, which is the subset of the dataset called Distress Analysis Interview Corpus. These interviews consist of both audio and visual recordings, as well as transcripts from 189 participants. To address the dataset's class imbalance, where non-depression samples dominate, we applied data augmentation techniques such as random masking of questions to expand the depression dataset during training. To evaluate our model, we compared its performance against several state-of-the-art multimodal models for depression detection and emotional recognition, including models like the Tensor Fusion Network, YLSTM 1D CNN, and Multimodal Transformer. And additionally, we also benchmarked against context-aware models such as GRU, YLSTM-based methods. In terms of performance, HiQuE outperformed all baseline models across key metrics like precision, recall, F1 score, and weighted average. As shown in the table, HiQuE achieved a macro average F1 score of 0.79, outperforming the best baseline model with an F1 score of 0.75. So these results demonstrate the effectiveness of our hierarchical approach in combining multiple modalities and improving depression detection. To further test HiQ's generalized ability, so we evaluated its performance on two additional datasets. The DIGWAS dataset, which includes questions not present in the original DIGWAS dataset, and the MIT interview dataset, which focuses on stress level prediction and job interview performance. So HiQuE showed promising results in both scenarios, indicating that our model is adaptable to a variety of interview settings beyond clinical interviews. Our evaluation study compared three approaches: non-question embedding, question embedding, and hierarchical question embedding. So we found that segmenting interviews into question-answer pairs significantly outperforms treating the entire interview as a single sequence. And moreover, adding hierarchical position embedding takes it a step further. By taking questions as primary or follow-up, we force the model to capture the hierarchical relationships and importance of questions. So this hierarchical approach proved most effective in depression detection from clinical interviews. We present a case study on samples from our test set to assess the effectiveness of decision-making process of HiQuE. So that we looked at two individuals, one with depression and one without. Specific audio, video, and text responses are provided in response to the primary question. What's one of your memorable experience? And the follow-up question, can you tell me about that? So red rectangles in facial features or yellow highlights in the textual features in the figures indicate distinct characteristics between a depression case and a non-depression case. As shown in this figure, the non-depressed person responded quickly and enthusiastically. They smiled and their voice showed a range of tones. Our HiQuE model picked up on these visual cues strongly. However, in contrast, the depressed individuals struggled to recall positive memories. They spoke about regrets, or their voice was unstable and their expression remained neutral. Here, HiQuE focused on the content of their words and vocal patterns. So this study showcases HiQuE's strength in integrating different types of data, what people say, how they sound, and how they look. So it captures the flow of the conversation and balances information from all these sources. Lastly, I like to conclude this presentation on HiQuE. So HiQuE's key strength lies in efficiently capturing the hierarchical structure of questions in clinical interviews. So this allows the model to explore correlations between different modalities, extracting crucial information or accurate depression detection. And we found that HiQuE focuses on questions specifically related to depression, utilizing attention scores to make its final decision. So this approach mirrors the expertise of clinical professionals during interviews, where the interplay of responses is critical. What's particularly promising is HiQuE's ability to generalize to unseen questions. This opens up exciting possibilities for future applications. Looking ahead, we plan to extend HiQuE's applicability to other speech-related tasks. We are also eager to explore further advantages of hierarchical question embedding in various contexts. So I'm gonna wrap up my presentation. So thank you for listening. I'm happy to answer any questions.